we're going to talk about bitwise and Boolean operators, and we're going to go through whole bunches of these. That was kind of the teaser. Let's talk about Boolean first. You should be very familiar with Boolean. Okay, so like for example, this is a Boolean OR. Okay, if either of the values, so I can have an example of 0x3f or 0x00, this should result in 0. I take it back. This should result in 1. 0x01 or 0x01. And I think I'm going to crank down my font just a little bit. I think I'm a little bit overkill. Let's go down to about 36, 24. Okay, I think you can handle 24. So those are so that's going to result in something like that. And so these are Boolean. And so it doesn't matter what they are. It matters whether they're 0 or not. There is Boolean and. Let me give an example of that one. I'm going to do the exact same one. 0x3f and 0x00. Kind of like that arrow thing. Okay, this is going to result in a 0. Both of them have to be non-zero. Okay, or 0x01 is another way to represent that. And so the change that's occurring right now is all of you CS guys for the longest time have decided that have used whole bytes as a Boolean character as either a 0 or 1. But now you have to look at the whole word. And basically the idea is if it's 0, it's 0. If it's not 0, if it's anything but 0, it's 1. That's how these are treated. What other Boolean do we have? There's not much. Let me see. There's like greater than, but that's not Boolean. So those are just C operators. And so I can't think of too many other operators that we have. There's and or, and there's one more. Not. Boolean not. Okay? So if I were to not 0x01, it would result in 0. If I were to not 0x9a, it would result in 0. If I were to not 0x00, it would result in 1 or 0x01. Okay? So those are really our Boolean operators. Let's go back and do other C operators that are common. Okay, equals. Okay, this is setting things equal. If I have a variable var, I'm going to be original, is equal to 0x39, it's going to set var equal to 0x39. Contrasting asks if they are equal. Okay, this is asking, is var, if I put var equals 0x39, it's going to returns a Boolean if they are equal or not. Okay? That's the basic. And so if var were already set to 39, I would return a Boolean true. And so we use this a lot. We'd be like, if var equals 0x39. And then if it were true, it would get into this and work its magic inside of those squirrely braces there. We call those squirrely braces just in case you get confused. So those are those. Let me see. There's greater than. Whoops. Greater than. Let me do this. Greater than. Less than. And then C has some other fun ones. Plus plus, minus minus, plus equals, minus equals. I'm going to ask you to go and look these ones up. This one adds something to our current value. So if we have var plus plus, it just increments it. Var minus minus just decrements it. Var plus equals 15 adds 15 to var and puts it back into var. Var minus equals 12 subtracts 12 from var and puts it back into var. Times equals also works. So there's also times and plus, and minus and divide. There's modulo. I'll let you look that one up. And then we can have plus equals, minus equals, times equals, divide equals. All of these can do the same. I'm sure that there's a modulo equals. So I'll say this might be confused. Modulo. Go look it up. Okay, I'm not doing it directly, and I don't teach it very much. So it's a kind of a special case for taking a percent, or taking a division and asking for the remainder. So you can look those up, and I want you to play with these just a little bit. But what we really want to get down to here is we want to get to the bitwise operators. And by the way, most of these are similar to the other languages that you have. Okay, there's no question. Okay, bitwise or, that's a pipe that I drew. That's on the I or an L. It's a pipe. It's under the backslash. Shift backslash gives you the pipe. Bitwise or. So if I have 0x, let's do some simple numbers. 0x01 or 0x 10. This is going to result in 0x11. Why does it do that? Well, let's take it back to binary. Binary 0, 0, 0, 0. Like that. Binary 0, 0, 0, 0, 0, 0, 0, 1. Okay, is the first one. And then we're going to OR it with binary 0, 0, 0, 1, 0, 0, 0, 0. And then we go through each bit, and we go through each one. And the first one is 0, because neither of them are true. 0, 0, 1, 0, 0, 0, 1. So we're ORing them. So the difference physically is that we have one pipe versus two pipes. Okay, that's a double pipe for a Boolean. It's a single pipe for a bitwise. And so that gives it, so you can practice this a little bit with what you want to do. Okay, if that's true, then bitwise and so let's do an example. 0x34 and 0x98. I didn't do these in advance. I'm going to have to think about what these values are. So 0x34, this should be binary. 0b, I'm going to B for binary. 0, 0, 1, 1. 0, 1, 0, 0, 0 is 34. And then we're going to AND binary 0, let me see, 1, 0, 0, 1. Oh, I did this wrong. Sorry, some of you are confused. And then this one is 1, 0, 0, 0. That's the 9 and the 8. And so we can go through each byte on this, each bit, and this results in 0, 0, 0, 1. And I'm having a hard time. That looks like a 0, 0, 0, 0. There's only one bit that overlaps between all of those, and that's bit 4. Okay, this one up here. This one up here is bit 4, and both of these were true, and so it results in something weird. So we have to do this kind of in a and we have to do this on a bitwise basis normally. It's hard to do it in hex without thinking long and hard about it. that this one is going to result in, what is that going to be? 0x10 is going to be the hex value for that one. Okay, so that gives us that one. And I'm trying to think if there's anything else that's bitwise, and there is. There's, instead of exclamation point, there's tilde, bitwise not, and this bitwise kills every bit, changes it, toggles it. Okay, and there's a couple more. So bitwise not. If I do bitwise, of 0x 5, or we can do FA. Okay, FA. So let's do it binary wise. This is going to be 1111 1010 is A, and that should result in a binary value of, let me put this, 00000101, or in hex 0x05. Okay, so don't worry that I have all these memorized. I've been doing this, taught this class a lot of times, but I have all the hex to binaries pretty well memorized at this point. So that should give you a good idea of that one. Exclusive OR. This one's weird. Okay. Exclusive OR has to be bitwise. There's no Boolean version of this that I'm aware of. The bitwise OR, the Boolean expression on this doesn't exist. We have to do it bitwise only. And so exclusive OR is a weird thing. And I'm going to go up and do this on the whiteboard because I don't have a good way of doing it on a marker. Let's get this out of here. And I'm going to do what's called a truth table. Let's do AND first for a 2-bit A and B and X 00011011. Those are all 4 possible combinations that we have there. And so for an AND, they both have to be true. Okay, so we know that one. We can do the same thing for OR. If we're going to do OR, OR, I'm just going to say it's Y 0111. Okay? Okay. Exclusive OR, let's start over and so we don't get muddled. We do XOR, exclusive OR. It toggles. If things are the same, it reproduces 0. If things are different, it produces a 1. So our two inputs, A and B, 00011011 binary order. If they're the same, it's a 0. If it's different, just like that. Okay? And so this is a weird one, but it does something for that other code that's really interesting. If you remember, in the other code, there was one in there that said P1DIR exclusive OR equals 0x01. That was the code that was there. And so let's just imagine that we know it, or sorry, not P1DIR, my mistake, P1 out. Okay? And so let's just imagine that we knew that P1 out was 0x01 when it started. Okay. So, in other words, we only care about this bit, this one's here, and if we exclusive OR that one, if it's 1, exclusive OR with 1, that's going to result in 0. Okay? We're going to shove it back in here. Now it's 0x01 is P1 out. And we're going to exclusive OR that with, so sorry, it's going to result in 0. We're going to exclusive OR that with 0x01. Well, that means that the two are going to be different, and that's going to result in 1. So now it turns into 0x01. It makes this automatic toggle, is what exclusive OR does, and they just combine it with exclusive OR equals. Okay, there are 2 more that I want to introduce you to. Bit shift, don't say it fast. Okay, bit shift, that's a bit shift right. Bit shift left. And let me, we're going to finish this one off with these guys here. But bit shift left, if I had 0x38 and I bit shifted this left by 3, we have to look at this in the binary. So 38 is going to be 0011 1000. And what I'm going to do is, if it's shifting to the left, I'm going to add on 3 more zeros. I'm going to cut off the most significant ones. And so this turns out to be, whatever that turns out to be, 1100. 1100, let me see. A, it's more than A, B, I forget which one that one is. Been doing it a long time, still don't have them all perfectly memorized. It's either C or D. Okay. The trick with this is that's C. So 0x0. Okay, let's do another one. 0x38, I'll do the same thing. Right shift by 4. So we start with the original 1, which was B00111000. Okay? And then what I'm going to do is I'm going to cut off the least significant bits and add in 4 zeros at the top, and so this ends up being 0x03. And no wonder we cut off the least significant nibble. We were only left with the shifted version of that nibble, 0x03. And so these are all things that we can do in our microcontroller. If we want to go back to the code, just to look at what's going on with what they've got. They have another one, and I don't have time in this video to go over the OR equals with you, but that's another one. But this is going to be individual bits. So we need to do one for the OR equals. Exclusive OR equals, though, does a toggle, and then we wait, and then it toggles again. And so there's only one thing. If you look at the old code, okay, I had 2 delay cycles in here, and I was forcing. Okay, so this might be more elegant code if whoever's reading the code understands what an exclusive OR does. So there's a big discussion on what elegant code means, and I'm going to leave it with that. There's elegant code, and then people make it so elegant that only they can read it, even with the best comments. And it's just really a challenge to make good code that everybody likes.